Okay, so in this video we're going to continue working with these two standards. And we talked about Ohm's law before and its simple circuits before. This time we're going to really focus on the difference between series and parallel. And we're going to apply Ohm's law so that we can understand the difference between a series and a parallel circuit. Okay, so the first thing we're going to do is we're going to actually look at a simulation of each of these kinds of circuits. So we saw these in class already, and what we saw about a series circuit was that in a series circuit the bulbs were dimmer than they would have been in a regular circuit. So let me just build a regular circuit real quick so we can compare, or the simple circuit rather. So we can compare these, okay? So you can see that in this case, the series circuit, these electrons are moving more slowly and the bulbs are more dim, okay? And then you can see here in the parallel circuit, the electrons are actually moving faster than they are here, and they're just as bright as they were in that scenario, okay? And so the question here is why? What's going on to make this happen, okay? And we can answer this by looking at Ohm's law, which we talked about in the last video. Okay, so let's start with this one. Electrons flow out of the battery, and then they're forced to go through both of the different bulbs. Okay, so they go through this bulb and that bulb. Okay, so in this example, these bulbs have a resistance of 10 ohms each, and the battery is 9 volts, so we can do some calculations here. So before we do this, I guess the best place to start would be with the simple circuit. So if we had a 9 volt battery and a 10 ohm resistance, we could solve for the current here using the V over R equals I, okay, Ohm's law. So if we have 10 volts and, 9 volts and 10 ohms of resistance, that's going to give us a current of 0.9 amps, or 900 milliamps, okay, which is a decent amount of current, okay. Well, if we compare it back to here, well, these electrons have to go through both of these bulbs, which is 10, 20 ohms of resistance that each electron is going to experience, okay. And so if we do that calculation, we say, okay, 9 volts over 20 ohms is going to give us a current of 0.45 amps, or 450 milliamps, okay? And so you can see that it's going to have half the current here because we have twice the resistance. Okay, and so that's why in the series circuit we have a smaller current. Well, if we look now at the parallel circuit, it's going to behave a little bit differently. And so what's happening here is we have the 9 volts, and then we have a bulb, and then we have a looping to another bulb. Each of these represents 10 ohms of resistance. And this acts a little bit differently because what's going to happen is there's going to be current going through each of these loops. Okay? And so the current's going to kind of split off. You're going to have some going that way and some going that way. So each electron is going to go through either that bulb or that bulb. Okay? And so the way that we handle this situation is look at these loops separately, because we look at the path an electrons could take. So it could go this way, or it could go that way. And so we'd say, okay, so V over R is equal to I. We're going to do this calculation for each loop. So the voltage is 9, the resistance is 10 ohms, okay, and so we get a current through that bulb of 0.9 amps again. So we get a current of 0.9 here, and you do the same calculation here and you get a current of 0.9 there. Okay, so there's 0.9 amps flowing through both of these bulbs. Okay, which means though, if this battery has a current of 0.45 amps flowing out of it, and this battery has a current of 0.9 amps flowing out of it, that this battery right here is going to have 0.9 plus 0.9, so this battery has actually 1.8 amps flowing out of it. Okay, and so you can see that the difference here is that in a parallel circuit, it's like you're just having multiple single bulbs powered by the battery. If we look back at the animation, they're kind of act independently of each other. Like they're not in the series circuit. If we were to disconnect a bulb, then the whole thing goes out. But in the parallel circuit, if I disconnect this bulb, the other bulb keeps going. And you could see that it didn't even change. The brightness didn't change at all because it couldn't even tell it happened. Okay? And in the same way, if we add another bulb, okay, to this parallel circuit, we're going to draw more current, but pay close attention to these bulbs, they're not even going to notice. Okay? And so in this case, we're using even more power from the battery. The current through this part is moving even faster, okay? But we're still getting the same current through each bulb. And that's kind of the basics of a parallel circuit there, okay? Here we have another series circuit, with this time with 3 bulbs, each with 10 ohms of resistance, powered by a 12-volt battery, okay? So the question I have for you is how much current is going to be used in this circuit. Okay, so go ahead and figure out how much current will be consumed in this circuit. Okay, so you can apply the same principles we used in the example before. So you can say, okay, V over R is equal to I, the total current, and in this case, the voltage is 12 volts. Okay, then we have 10, 20, 30 ohms of resistance. Okay, if we divide those, 12 over 30 is going to give us about, this would be 0.4 amps of current through this circuit. Okay, and let's do an example of a parallel circuit. Okay, so again, 12 volts. Let's say that we have 1, 2, in this case we'll do 3 bulbs connected. Okay, and I want you to find the current through each bulb and then the total current coming out of the battery. Okay, oh, and these are 10 ohms each. Okay, so current through each bulb and then total current coming out of the battery. So V over R equals I. So we could say 12 volts over 10 ohms is going to give us 1.2 amps, or 1200 milliamps if you're wondering. Okay, so if each of these has 1.2 amps, then 3 bulbs with 1.2 amps is going to give us a combined current of 3.6 amps coming out of the battery. Okay, and there you go. The one other thing I want to mention here is kind of the principles of circuits and kind of what's going on underneath. And so let's go ahead and I'll show you, we're going to revisit this example and maybe one others. So from this last calculation, we found that there was 0.4 amps of current going through this whole circuit. Okay, the next question I have is what is the voltage drop across each bulb? And so what I'm saying is this. In our analogy, we talked about a ski lift before. And so if we go up on the ski lift, we're raised up 12 volts. Well, the electrons have to go down back to 0. So they have to lose 12 volts again on their way back as they go back to 0. Okay? And that drop of those 12 volts occurs between the resistance in their circuit. Okay? And so every time that electron runs into resistance, it's going to lose some voltage. Okay? And so it would be like you're skiing down the hill, you go to a flat part, it's kind of flat, and then there's a drop when you cross this resistor. So there's a drop here. Okay, and then you're skiing along, and look, there's another one, so you drop again. Skiing along, and there's another one, So you drop again. Now you're back down to 0. Now, if we look at this, they're even amounts of resistance, or they're the same amounts. So clearly they're going to be the same drop across each. 12 volts divided by 3, that should give us a drop of about minus 4 volts across each resistor. Okay, well, we can prove this again using Ohm's law. So V over R equals I. So we know that the current through the circuit is 0.4 amps, and we know the resistance of each of these bulbs, then we can calculate voltage. So we say, okay, V is equal to 0.4 amps divided by 10 ohms. We multiply the 10 ohms up to there, and we get V is equal to 4 volts. Okay, and so that means that across this bulb, the electrons lose 4 volts. Across this bulb, they lose 4 more. So minus 4, minus 4, minus 4, back to 0. Okay, and this applies to all circuits. Okay, they have to start with, where they start with a certain amount of voltage. By the time we get back to here, it has to go to 0. And this is kind of one of the problems of having a short circuit, because if we short out the circuit, there has to be a voltage drop here at 12 volts, but there's nothing for it to drop through, and so things are just going to get really hot as the wire for itself forces the electrons to slow down. In a parallel circuit, the electrons, remember, can choose either path, so they can go either way, and they always have to get back. So if they start at plus 12 here, they have to get back to 0 down here, which means that they're going to experience a voltage drop of minus 12 across each of these bulbs. Okay, so that voltage drop is going to happen across either loop. And so this would be like, I went up on a ski lift, and then I could have gone down this route here, or I could go down that ski route there. Both are going to take me to the bottom. Okay, and so that was a little bit more with circuits. We'll work on this a little bit more in class. Hopefully that was making sense. Please let me know if you have any questions.